Hello, I'd like to go over a couple types of problems that students have been working on in class this week. What we have before us here is what's called a composite figure, and it's called a composite figure because it is made up of more than one prism. So, if we want to find the volume of this entire composite figure, what we first need to do is we need to break apart this figure into two prisms. And there's a couple different ways that can happen. I'll show you the first way. And to help me see where the boundaries of the prisms lie more clearly, I like to color in each prism. So there's one of the prisms. And here's another. Now, to show you an alternative way you could break apart this figure, you could also break this figure apart so that there's a rectangular prism on the top here, and then a larger prism serving as kind of the base of the composite figure. But I'm going to find the volume of this entire figure using this orientation here. So in order to find the total volume, I will need to find the volume of this prism in red, we'll call A, and I'll need to find the volume of this prism in green, which we'll call B, and then once I've found the volume separately for both, I'll add them up to find the total volume. Now, one of the formulas that we can use to find the volume of a rectangular prism is using this equation here, where volume is equal to the length of the prism multiplied by the width multiplied by the height. And we'll need to find the volume of prism A and then prism B using this formula. And again, once we've found those separate volumes for each prism, we'll need to add those volumes together. And again, we'll also need to identify the length, width, and height of each prism. So starting with prism A, I need to determine its length. And that length is represented by the green marks I made here. So each of these green marks are equal and have the same value. So here we can see the value of each of these lengths is 2. And I'll just plug that into the formula like so. Secondly, I need to determine the width of prism A. And I like to think of the width as the part of the figure that gives the depth or 3D quality to the figure. So you'll notice that these width values are kind of going off in a diagonal type direction, as opposed to the length is more side to side, okay? And the height is going to be up and down. So width is that value or that measure that is going to be extending off in a more diagonal type direction. So we don't see any of these measures defined. But down here we do see that this 5 identifies the width as 5 here, 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 as well as there. So we know that the width of A is 5. Now the height, as I mentioned previously, it's going to be more that up and down type measure. So it's measuring the distance from the base of the figure to the top. And luckily this is nicely labeled, and we see the height is 6 inches. So we have an expression here for the volume of prism A. Now we're going to repeat these steps for prism B. And again, we need to identify a length, width, and height for B. So again, highlighting where I'm going to be measuring the length, I'm just going to draw these green lines here. So the distance from this location to here, as well as from here to here and here to here, all measure the length of B and are all the same value. However, they are not clearly identified. We have to do some investigative work here to figure out what these values here are going to be. And what we do know is the length of the entire figure, is 7 inches. But 7 inches is not the value for this length here. This length here is noticeably shorter than the full length of the figure, which is 7. So what we need to recognize here is that this 2 added to the value here that we're looking for should add up to 7. So one way we could think of that is subtracting this 2 from 7 to get 5, or know that 5 added to 2 would give us the total length of the figure, which is 7. So the length of prism B is 5 inches, which we're going to plug into the volume formula over here under volume B. Now luckily we already know that the width of B is 5 inches. So all we need to determine at this point is the height of prism B. Well, that height is again not clearly labeled, but we do have enough information from the entire figure to determine what this value would be, or this value, since these corners both represent the height of prism B. So looking on the other side of the figure, we notice that the height from the base of the figure to the highest point of prism A is 6 inches. Now we also notice that on the far side here of prism A, we see that this distance is 3, meaning that this distance, which is the same as this distance, added to the value here has to give us a total of 3. So the only number that is going to add with a whole number 3 to give us a whole number 6 would be 3. So the height in this case will be 3. So we have a nice expression here for finding the total volume of this composite figure, which I've just highlighted there. And I'm going to record that expression on this line here. So we're going to add the quantity 2 multiplied by 5 multiplied by 6 to the quantity 5 multiplied by 5 multiplied by 3. Now we just need to evaluate this expression here, and that's going to give us the volume for the entire composite figure. So I know 2 multiplied by 5 is 10. When I multiply that 10 by 6, I have 60 cubic inches. And this exponent 3 reminds us that these units are, in fact, cubic units because we're talking about volume. Evaluating the expression for volume B, I know that 5 multiplied by 5 is 25. And I know 25 multiplied by 3 is 75. And again, that's 75 cubic inches. So the last step is adding the volume of prism B, adding the volume of prism A to the volume of prism B. Which will give us a volume of 135 cubic inches. So again, to briefly summarize what we did here, we first looked at the composite figure. We broke it up into 2 separate prisms. We identified one of the prisms as prism A, one of the prisms as prism B, and then we use the formula for volume, length times width multiplied by height, to find the volume of prism A and the volume of prism B. And lastly, we added these 2 values together to get the total volume of this composite figure. So we want to make sure that we're only adding at the very, very end. A common mistake that I've seen in class is many times students will correctly identify all the dimensions of a composite figure. But instead of finding the volume of each prism by multiplying those dimensions, they'll instead add them and then add them again. So we want to make sure that we're multiplying at first to find the individual volumes, and then finally adding the separate volumes together to find the volume of the composite figure. I hope this helps clarify the steps needed to find the volume of a composite figure.